The Ohio chapter of the American Academy of Pediatrics has partnered with Cardinal Health Foundation to create Good4Growth, a program to promote childhood development by helping children, their families, and communities to build safe, stable, and nurturing relationships. As part of this ongoing partnership, leaders within the chapter are providing Talk with a Doc presentations for both the Cardinal Health community and beyond. Previous Talk with a Doc presentations by Dr. Robert Murray have focused on topics such as the mother-infant relationship and relationship-based discipline. Today, I've been asked to talk about stress in the brain. Although this talk will build upon many of the themes previously mentioned by Dr. Murray, I'll be essentially starting from scratch to make sure we're all on the same page. When I was first asked to speak about stress in the brain, I have to confess that I had two initial thoughts. The first was, Here are two subjects that could easily make for hours of discussion, and I need to discuss them both in 30 to 40 minutes. So now I'm actually living a little stress on the brain. The second thought I had was an image. The old anti-drug use campaign, here's your brain, and they show an egg, and here's your brain on drugs, and they show a frying egg. That's not really accurate with stress, though, because stress can actually be good for the brain. The stress of public speaking, for example, has motivated me to prepare at least a few of my thoughts in advance. So some stress can actually motivate and build confidence and a sense of competence. That's one of the nuances that we'll be discussing a little later in the talk. But I want to begin my talk by first talking about the brain, because understanding how the brain develops initially and then rewires itself in response to experience is fundamental or foundational for understanding how stress ultimately impacts both brain structure and function. I'd also like to share 5 critical concepts, and the first is on the next slide. To appreciate the consequences of stress, you first need to understand how the brain develops and functions, what stress is biologically, and how stress triggers changes at the genomic, neuronal, and behavioral levels. With this in mind, I have the following objectives for today as well. The first is to review the 3 mechanisms and 5 principles of brain development. This is not to turn all of you into neurosurgeons, but just to discuss the basics. Think of it as Neuroscience 101. The second is to define adversity and stress and resilience in biological terms, because we all have vague ideas what these mean, but to really get a handle on them, you need to look at the biological responses, not the precipitants. And the third is to discuss a few of the numerous implications of this perspective. Our focus today will be primarily on implications for how we raise our children, but clearly there will be implications for how the old dogs manage stress as well. Starting then with Neuroscience 101, Dr. Murray alluded to a few of these basics, but I want to review them briefly. And there will be 3 cellular mechanisms, how to assemble the brain, and 5 overarching principles. If you wanted to build a brain, you would need 3 components. The first would be the numbers. You need enough clay before you begin to sculpt. The number of neurons is a function of neurogenesis, or the number of neurons that are being born, and the number of cells that are dying through cell death. The second, you need connections. You need them to share information. The number of connections, or synapses, is a function of synaptogenesis, meaning the beginning of those connections, and then pruning when those connections are eliminated. The third is you need the speed of communication. You need them to share information fast. The speed is a function of myelination, where other cells wrap the axons of the neurons with fat, and that insulation dramatically speeds up the speed of communication. There's a recurrent motif in brain development where there is overproduction to ensure redundancy and completeness, followed by elimination of the excess to make this system more streamlined and efficient. We see this with regard to the numbers, where most of the neurogenesis and the cells being born happens in utero, as well as cell death. But there are a few exceptions we'll get to later on. Ongoing neurogenesis is pivotal in areas like the hippocampus and the prefrontal cortex, as they're essential for learning and adaptive behaviors. Ongoing cell death in response to trauma and stress, for example in the hippocampus, helps us understand how stress can really be a double whammy. It can decrease the production of new cells and kill off the ones you've got. So from birth to 18 months, there's a dramatic increase in the number of synapses and connections that are made within the brain. By the time you're about 18 months, the analogy has been made that there are as many synapses in the brain as there are leaves in the Amazon rainforest. That's a lot. Between 18 months and 36 months, there's a dramatic pruning where the ones that aren't being used are eliminated. So again, there's overproduction to ensure completeness and then pruning the excess. It turns out that this overproduction of synapses and then pruning occurs again in early adolescence. So if you've sometimes wondered why your 12-year-old acts like a 3-year-old, there may actually be a biological reason as to why. Finally, with myelination, that's like going from dial-up to broadband, and it's also the final step in the maturation process. In general, the more myelinated, the more mature. Because it makes sense, actually. It's hard to branch out new synapses when you're coated in fat. So you'll be happy to learn that's it for the basics. But to really understand brain development, there are a few overarching principles as well. The first is that brain development is experience dependent. Experience is translated into neural activity in the brain, and that activity influences all three of the cellular mechanisms we just discussed: neurogenesis and cell death, synaptogenesis and pruning, and myelination. In fact, one of the most potent inhibitors of myelination of the prefrontal cortex is alcohol, which helps understand why we need to be so careful about adolescents drinking. So what does this mean? Well, experts say it's useful to think about the different parts of the brain as if they were different muscles. The question then becomes, are we strengthening the structures underlying fear and aggression and impulsive behaviors, or are we strengthening the structures underlying the ability to self-regulate, to be pro-social, and to be introspective? We have to get those early experiences correct because they can literally be hardwired into the brain. This is not saying that adversity is destiny, but early experiences cast a long shadow due to their role in building the early architecture of the brain. And that brings us to principle number 2. Ask any builder, and they'll tell you that the most important part of a building is the foundation. If the foundation is poor, the integrity and value of the entire house is significantly diminished. The brain is similar in that the architecture is built from the bottom up. And the question then is that initial foundation sturdy or weak? Because we know that synapses lead to circuits, and those circuits lead to pathways, and those pathways ultimately lead to behaviors. And so those early experiences are truly foundational. Skills beget skills, and deficits beget deficits. And we know this from the work of Hart and Risley and others, where disparities and gaps appear very early and then are maintained, and if anything, they get wider as time goes on. Again, disparities in language can be seen as early as 18 months, and this disparity gets wider over time. This is what underlies that 30 million word gap you may have heard of, that by 4 years of age, some children have heard 30 million more words than other children. So brain development is experience dependent, it's cumulative, and it's also integrated. In fact, some have called the human brain the most complicated 3-pound mass of matter in the universe. In our attempts to understand the brain, we often tend to focus on discrete functions. We dissect out language versus social versus cognitive skills. While there are discrete anatomic regions in the brains that tend to be more responsible for one skill versus another, the brain is much more like an intricate spider web. For example, if a child has hearing difficulties, that can translate into speech difficulties, and that can translate into social difficulties. So most human behaviors, like achievement test taking, utilize many different skills at the same time. I often make the analogy that brain and child development is like playing a game of solitaire. We all know that if you don't get all 4 of those aces early on, you're not going to go very far in the game of solitaire. Similarly, we don't need just cognitive skills. We also need language skills and social emotional skills to be successful. So brain development is experience dependent. It's cumulative with foundational effects. It's integrated, meaning that we need not just cognitive skills or language skills or social skills, but the whole set of skills. Finally, it's also dynamic. This is what sets the brain apart from other organ systems. When we talk about the brain being dynamic, what we're really referring to is this idea of plasticity, which refers to the brain's unique ability to literally rewire itself in response to experience. Experience influences not only the foundational architecture, but the ongoing connectivity and functionality of the brain. There are actually 2 different types of plasticity. The first is synaptic plasticity. This refers to the strength of individual connections. So we can go from a synapse whispering to each other or shouting at each other. And this type of plasticity is lifelong, which is good news for old dogs like me. On the other hand, there is cellular plasticity. This refers to variations in the number or count of synapses. This is much more powerful. It's like going from one person shouting to a stadium shouting. The problem is, overall, cellular plasticity declines with time, and it's declining dramatically by the time children enter school. This helps us understand why our focus on parents and early child caregivers is so important. By the time children enter school, most of the power of the brain's plasticity is already waning. Cellular plasticity persists in some areas like the hippocampus, which points out our final principle, which is that not all areas of the brain are the same. Brain development is asynchronous, meaning that different structures mature at different rates and different times. One of the beauties of being a pediatrician is you can literally witness the maturation of the brain as you watch new skills appear in a child. At birth, the brainstem and the vital functions it serves are well formed. Brain maturation proceeds from the back of the brain to the front of the brain. Next, we have the cerebellum, which is a bit of an enigma because it starts maturation early and it finishes maturation late. Initially, the cerebellum was thought to mainly play a role in the planning of movements, but we now know it's actually playing an important role in the planning of other activities as well. But aside from the cerebellum, the brain maturation proceeds from the back to the front. So next we have the occipital lobe, which allows for visual processing. So we know early on babies are able to fixate on a face. The next are the parietal lobes, and their maturation allows for the integration of sensory and movement, so we have children offering a social smile. By 15 months, the limbic system announces that it's maturing because now we're having emotionality, we're seeing tantrums. Shortly thereafter, the temporal lobes and language skills evolve to the point that we're trying to say, use your words. If all goes well, the frontal lobes mature well into the 20s, allowing for what's called executive function. This differential or asynchronous maturation has important implications. Let's just consider two structures. Consider the amygdala, which is part of the limbic system, which we can think of as the on switch for the stress response, versus the prefrontal cortex, which we can think of as the off switch for the stress response. So when we compare these two structures, we can see that their maturation at different rates leaves the brain somewhat out of balance. Consider the prefrontal cortex versus the amygdala. The prefrontal cortex is cool thought, and the amygdala is sort of hot. The prefrontal cortex is judgmental versus impulsive, reflective versus reactive. The prefrontal cortex basically says, let's think about it versus just do it. But the kicker is, the prefrontal cortex isn't biologically mature until 24 years of age, whereas the amygdala is biologically mature by 18. This slide has significant implications. First, it's never too late to help adolescents. The prefrontal cortex isn't structurally mature until 24. Second, there are two ways to bring more balance to the brain. We can either decrease stress in the role of the amygdala or increase executive functions in the prefrontal cortex. And the good news is that social emotional skills do both. They decrease stress and they demand us practicing our executive function. Third, this sort of makes sense developmentally. It's probably better to have the shoot first and ask questions later when you're younger, so it's good to have the on switch mature before the off switch until we're a little wiser and we know what we need to be afraid of and what not to be afraid of. Fourth, this is sort of congruent with our own experiences. We know we make great decisions when we're cool, calm, and collected, but not so much so when we're emotional. That's because the on switch is screaming and the off switch is still whispering. Fifth, this helps us understand why young children are somewhat predisposed to stress. We see that in their tantrums every day. The amygdala is screaming and the prefrontal cortex is still just whispering. Sixth, if we want children to learn anything, first we need them to be calm. We need to turn off the amygdala and allow the prefrontal cortex and hippocampus to do their work. And seventh, you can see how significant adversity and the absence of safe, stable, nurturing relationships can lead to a vicious cycle of stress. And I'll explain this further in just a moment. But first, I want to redefine stress in the context of this biology. This is our second critical concept. The only objective way to measure stress or adversity is to look at the physiologic response. This gets at the fact that stress or adversity is a very subjective thing. A barking dog, for example, may trigger one child to say, "Ooh, puppy, let's play," whereas another might be screaming in terror. One child's challenging opportunity is another's overwhelming adversity. So to get a handle on adversity and stress, we need to begin by looking at the individual's biological response. If we look at the physiologic stress response, these are the most basic steps. There's a precipitant, an event, a trigger, that in turn is perceived by sensory information and interpreted within the brain, that leads then to a biological response. Let's dig a little deeper into this third step because this is what we ultimately can measure. When we look at the physiologic stress response, the on switch is the amygdala. Once the amygdala identifies that a threat is there, it triggers the stress response through two pathways. The hypothalamic pituitary adrenal axis, in which the output is cortisol, which in turn influences many other organ systems, or through the sympathoadrenal medullary pathway, where the output is epinephrine and norepinephrine. These also influence many different organisms. The important point here, though, are these critical regulators. There need to be checks and balances. Stress is only toxic if it's not regulated. And that brings us to yet another critical concept. The stress response is a double-edged sword. Stress can be helpful. For example, if you're in the jungle and there's a tiger, that stress response is necessary for your survival. It gets your heart rate up, your blood pressure up, your muscles moving so you're able to escape. But what if that tiger never goes away? Today, we face paper tigers that never go away. An alcoholic dad, cyberbullying, poverty, racism. In fact, there's a documentary out now by Jamie Redford called Paper Tigers, and it looks at the effects of chronic stress upon adolescents and their academic achievement. Because stress is a double-edged sword, Jack Shonkoff and his colleagues have proposed a taxonomy of stress based on the biological responses, not the precipitants, the responses. A positive stress response is brief, infrequent, or mild to moderate in intensity, and it's what happens when most kids experience normal things in childhood. An inability of a 15-month-old to express their desires that can lead to a tantrum, a 2-year-old who stumbles while running, the beginning of school or childcare, and even for adolescents, the beginning of a major project. That big middle school project that takes weeks to plan, that can be very stressful. The defining characteristic of positive stress is that it is buffered by safe, stable, and nurturing relationships. So we can respond to the nonverbal cues of that 15-month-old. We can offer consolation to the 2-year-old who stumbled. We can reassure the toddler that we're coming back at the end of the day. And for the middle school child, we can help them break the big project into small, bite-sized bits and make it less stressful. The point here is that social emotional buffers allow return to baseline. So stress can actually build motivation resiliency if it's brief, mild, and infrequent. This is important because positive stress is not the absence of stress. We're not trying to put kids in a bubble. We're trying to give them the skills that they need to cope in a healthy, adaptive manner. But what about the other edge of the sword? What about toxic stress? A toxic stress response is longer lasting, frequent, or strong in intensity. You can see how extreme precipitants of childhood adversity could trigger this sort of stress response. And we'll talk a little more about the adverse childhood experiences later. But these are things like physical abuse, physical neglect, and measures of household dysfunction. With those events, there may not be enough social emotional buffering to turn off the stress response. And as a consequence, children are literally bathing in this toxic stew of physiologic stress. This can lead to potentially permanent changes through two biologically related but conceptually distinct mechanisms: epigenetics and neuroscience. Epigenetics help us understand how the environment changes us at the molecular level, and we'll discuss this more in a moment. Developmental neuroscience helps us understand how we have changes at the cellular level, which cells are talking to each other, and we'll also discuss this in a moment. But first, let's redefine some vague concepts like adversity and resilience and ground them in this biology. Adversity leads to physiologic stress. It can be positive if it's buffered by safe, stable, nurturing relationships, or it can be toxic if it's unmitigated by safe, stable, and nurturing relationships. Resilience, on the other hand, is the ability to handle adversity in a healthy manner. In the absence of those safe, stable, nurturing relationships, stress might lead to maladaptive responses, but in the presence of safe, stable, nurturing relationships, the stress response may build motivation and resiliency. As a consequence, you can see it's all about relational health. This is the science behind the Good4Growth project. Safe, stable, and nurturing relationships are the antidote to toxic stress. And we definitely need an antidote because toxic stress is able to change who we are at the molecular, cellular, and behavioral levels. So I'd like to round things up by giving some examples of how toxic stress can trigger changes at each of these levels, the molecular, the cellular, and the behavioral levels. At the molecular level, we can look a little deeper at the impact of stress upon epigenetic mechanisms. Epigenetics is part of a whole new frontier in genomic medicine. Epigenetics means literally above the genome and refers to changes in gene expression without changes in the DNA sequence. So the information in the DNA blueprint is still there, we're just not reading it. The old view is that the genome is very static. So there are examples like Huntington's disease, where we know if you have that gene, we know what's going to happen when you turn 50. The new view is that the genome is more like a very complicated set of molecular switches. Some are master switches leading to cascades that turn on other genes. Some of these switches are very sensitive to the environment. Some are very dynamic, like circadian rhythms, when we get sleepy and when we're awake. But some of these switches are programmed early and very stable, not only across your lifespan, but into your next generation. So I'd like to give an example of some epigenetic mechanisms that are responsive to stress. But let me begin with a disclaimer. I'm not picking on moms, and let me say that these changes are thought to be reversible. That said, we know that maternal stress results in methylation of the fetal glucocorticoid receptor. What does that mean? Methylation decreases the expression of this gene, resulting in fewer glucocorticoid receptors in the brain. This is a problem because the glucocorticoid receptor in the brain is part of a negative feedback loop. So methylating the glucocorticoid receptor gene essentially decreases the brake on the stress response. As a consequence, we have newborns with higher HPA activity and higher cortisol levels. Those are both great measures for toxic stress. Again, I'm not picking on moms. Dads play an important role in methylation patterns as well, and methylation is thought to be reversible. Interestingly, it can be changed by social supports and mindfulness-type yoga. The question then is, are we translating this information into practice and policy? Do expecting moms have access to prenatal care? Do expecting moms have the social supports necessary to buffer their stress? We know there are examples of programs such as the CDC's Legacy and Centering Pregnancy that do just that. Do we as a society provide maternal and family leave policies to ensure that all kids get a healthy start? So what about stress triggering changes at the cellular level? The brain is a good example, as stress changes which cells are communicating with each other, which circuits are getting stronger, even which brain structures are getting larger. So if we look at the impact of stress upon brain structures, we see that we have larger amygdalas, smaller hippocampi, and the dendritic arbors, the way cells communicate, are getting smaller in the prefrontal cortex. The net sum is that the on switch is getting yet stronger and the off switch is getting even weaker. Let's briefly look at an example of how this vicious cycle of toxic stress happens in the brain. If there's significant childhood adversity, we know that can lead to a chronic fight or flight response because of the differential maturation in the brain. The on switch is screaming and the off switch is still finding its voice. That chronic stress response, because of plasticity in the brain, can lead to changes in brain architecture. So, for example, if you look at the amygdalas of Romanian orphans, they are literally bigger. But it doesn't necessarily need to be a catastrophic event. If you look at the amygdalas of kids that are born to depressed moms, they also have bigger amygdala. We know that those bigger amygdalae can lead to a hyperstress response and ultimately to toxic stress. Ultimately, however, what we are really concerned about are stress-induced changes at the behavioral level. So how does stress influence behavior? Well, if you're a reductionist, you believe that all those changes we've talked about at the molecular and the cellular levels lead eventually to changes in behavior. But if you're a physiologist, you might think about it a little differently. They talk about three concepts. Homeostasis. This is the tendency to stay at the normal level. Allostasis. These are activities that we do to return to normal. And then they have this concept of behavioral allostasis. These are behaviors that allow us to return to normal, in this case, to turn off stress. Those behaviors may be adaptive initially, but they may be maladaptive in the long run. One of the best examples I can think of to illustrate this concept of behavioral allostasis comes from the Adverse Childhood Experiences, or ACE study. If you've never heard of the ACE study, don't feel bad. It's often been called the most important study you've probably never heard of. The ACE study looked at 17,000 middle-class, middle-aged Americans in San Diego. Most of them had attended college, most of them were in their 50s, and they asked them if prior to the age of 18, did they experience any of 10 different categories of adversity. On this slide, you can see that they looked at 3 categories of abuse, 5 categories of household dysfunction, and 2 categories of neglect. The first thing you can see from this data is that these experiences are very common. In fact, at first, there were doubts as to whether this data was really true. Subsequent data have shown that this is in fact the case, and these adverse childhood experiences are actually overrepresented in some populations, such as those who are in jail or incarcerated. So the researchers wanted to quantify this adversity, so they came up with an ACE score, where you got 1 point for each of the different categories experienced before that 19th birthday. I think the ACE study is an important study for everyone to understand, but let me first talk about some of the limitations, because this ACE score is actually a relatively poor measure of adversity for 3 main reasons. First, there's issues with recall. We're asking people in their 50s what happened to them prior to the age of 18, and we know that we tend to suppress memories we don't want to remember. There are also issues with repetition. So if you were sexually abused once versus every other week, it's still just 1 point for sexual abuse. And finally, there are issues with redundancy. So if your dad was an alcoholic but your mom preferred heroin, that's still just 1 point for substance abuse. So despite these limitations, they found a graded, dose-dependent relationship between adverse childhood experiences and all of these outcomes decades later. It's easy to look at this slide and to be overwhelmed, but I see potential. If all of these diverse outcomes are associated with adverse childhood experiences, there's at least the potential to impact all of these varied public health crises by preventing and addressing childhood toxic stress. But it gets even more promising if you just consider these big 5. And I know I've circled 6, but I tend to lump illicit and IV drugs together into substance abuse. So what do these big 5 have in common? First, they drive, at least in part, many of the other outcomes on this slide. So for example, if you're a smoker, it's going to increase your risk of lung disease. And if you're an alcoholic, it's going to increase your risk of liver disease. The second thing they share, though, is they are all very good examples of behavioral allostasis. They all transiently turn off the stress response, which is why we tend to do them in the first place. In fact, one of the patients in the ACE study had the insightful comment that it's really hard to get enough of something that almost works. All of these big 5 things almost work. They transiently decrease stress. So this forces us to look at adolescent and adult health in a completely different manner. Are we going to continue treating all these unhealthy lifestyles and symptoms of unmanaged stress? Or are we going to proactively address the childhood antecedents, the root or distal causes? This is why we are so excited about Good4Growth. It is an attempt to go upstream and address the root cause, toxic stress, by building up the antidote, relational health. So I apologize for throwing so much information at you in such a short period of time. So I thought I would close by just briefly summarizing all that we've talked about. First, we need to ground terms like stress and resilience in biology. Adversity triggers a physiologic stress response that can be either positive or toxic. Safe, stable, and nurturing relationships buffer that toxic stress. Resilience is the ability to respond to adversity in a healthy manner. People do not learn well when they're scared. The amygdala is screaming. The prefrontal cortex and the hippocampus are not being heard. Significant adversity in childhood can impact learning, behavior, and health for decades. So it's important that we understand the adverse childhood experiences study and that toxic stress is a mediator, as well as understanding early interventions that improve outcomes decades later, and that relational health and safe, stable, and nurturing relationships are the mediators. We need to minimize the potential precipitants of toxic stress, and not just the catastrophic, like violence and abuse, but also the routine, examples of poverty and maternal depression. And in fact, my next talk with a doc in May will be on maternal depression. We need to change the way adversity is perceived. Social isolation underlies many of the adversities. In fact, social isolation is the largest stressor, the inducer of the biggest stress response that we know of. On the other hand, social supports are essential, those safe, stable, and nurturing relationships. We can also change the way adversity is perceived by simply being healthy. We know when we get good nutrition, good sleep, good exercise, we're able to perceive stress in a different way. Finally, we need to proactively build healthy responses to stress. Make sure children feel understood. We can catch them being good by helping them discover their passions. There recently was an art presentation in Cleveland, and there was a quote from Henri Matisse, the Impressionist painter, who said, "I paint to forget everything else." Painting was Matisse's passion. That's what allowed him to turn off stress. We need to help kids discover what their passions are, healthy ways of dealing with stress. And finally, we need to be wary of unhealthy distractions. If kids don't discover their passions, it's very easy to get sucked into unhealthy ways of dealing with stress, getting lost in electronics, overeating, or substance abuse. Many addictions and unhealthy lifestyles are maladaptive attempts to cope with stress. We talked about behavioral allostasis and the fact that those initial attempts to deal with stress may actually be adaptive and then reinforced over time and then become essentially automatic. But they may prove to be maladaptive over time and in different contexts. This changes the way the medical profession approaches problems. It's not so much what's wrong with you, but what's happened to you. Many of our most intractable problems have their origins in childhood. The most costly chronic diseases, things like hypertension, diabetes, obesity, depression, are actually adult manifest diseases. Building family and community supports for young children is a medical prevention. That is why Good4Growth is so important to pediatrics. So if I had to summarize my entire talk into one slide, this would be it. I used this slide earlier to explain the physiologic stress response. So the question now is, how do we modify it to prevent toxic stress? First, we can try minimizing the precipitants. Clearly, we cannot put kids in a bubble, and that's not ultimately our goal. But as a society, what precipitants do we feel no child should have to experience? The biology suggests that no child should grow up in the absence of at least one safe, stable, and nurturing relationship. But what about things that make safe, stable, and nurturing relationships harder? Things like poverty, a parent's experience of adversity as a child, depression, or a dad who's an alcoholic. The biology says that these are now medical and in particularly pediatric concerns. Secondly, we need to maximize the social supports. Ideally, the safe, stable, and nurturing relationships begin in the home with the family. But all adults have the potential to build safe, stable, and nurturing relationships with children. Child care providers, pediatricians, teachers, coaches, neighbors. And finally, we need to build healthy coping styles. A basic rule of psychology is that it's far easier to teach an alternative behavior than to just stop or quit something. So what are kids' passions? How do we nurture those passions so they become healthy adaptations and escapes from stress, while at the same time building skills for the future? This is not easy. I know that. You know that. But it's incredibly important to always remember it's easier to build strong children than to repair broken men. Thank you for listening. This has been a presentation of Good4Growth, a program brought to you by the Cardinal Health Foundation and the American Academy of Pediatrics Ohio chapter.